One of the most important things that we really need to understand to do engineering is to understand numbers. Numbers are one of those things that you learn at a really young age, but sometimes I don't think that we understand them really well. We just understand that they're there and that we use them to do stuff. So numbers explain the world around us. They give values to things so that we can perform mathematical operators. Some things that numbers do for us, just some basic overviews of numbers, are they can tell us the size of measurement, so they can tell us an amount. They can allow us to make comparisons between things. They can help us analyze past situations or understand patterns. Numbers allow models to be made so that I can make equations to perform predictions on things. Numbers can be positive, negative, or zero. They can be whole values or partial values. And numbers can be any base. That's the number of digits that we use to describe our numbers. We use base 10. We have 10 digits, 0 through 9, to make up all the numbers possible that we use. All right, so again, numbers tell us the size of measurements. Things like a ruler will tell us how long something is. A thermometer will tell us how hot something is. A scale will weigh something. Price will tell us how much something costs. It really gives us an idea of the size of something. Numbers can allow comparisons. So what's the distance between you and your computer screen right now? What's the distance between you and the moon? Numbers can help analyze past situations, make equations. It can help us compare things like position and speed and how those things might be changing over time. And with that, we can make equations and use equations and models to make some predictions about how things might happen in the future. Numbers can be positive, they can be negative, or they can be zero. Zero meaning that there's the lack of something, that there's no change that's happened. Depending on your perspective, positive and negative numbers are just opposite directions of the same number. So right now, you're facing your computer screen. That means that forward might be your positive, and backwards, which is away from your computer, would be negative. Now, if you turn around, you'd say, no, forward is away from my computer and backwards is towards my computer screen. So it has a little bit to do with perspective and understanding. And as you turn around, notice that what was left is now on your right and what was right is now on your left. Another example would be positive and negative values of money. If I owe you $5, from my perspective, I have negative $5. From your perspective, you have positive $5. And so a lot of it's just perspective. The number 5 is still involved, but the sign changes whether it's positive or negative. Numbers can be whole values or partial values. Whole numbers meaning your integers, 0, 1, 2, 57. I could throw negative signs into here. It really doesn't matter. They're whole numbers. They're whole pieces of what we count with. Numbers can also be partial. Most things in life really are partial numbers. Decimals, 1.4, negative 9.6, pi, they're all decimal values. Another way to show a partial number is a fraction to show how much of a whole it is, such as 1/3, 1/2, or 31/7. So then we can get into what we talk about when we say that we use base 10 when we count. Numbers can be really in any base. We use base 10. It doesn't mean that those numbers are any more correct than any other base or any other system of counting. It's just what we're familiar with. So I wanted to just kind of quickly show how this works. If I have only these numbers up here to work with, that means if I want to count, I can go 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. All right, now those are the only digits I have to use. How do I count to 10? Well, the only thing I have left to do is just to recycle my numbers and put a 0 down. But to show that I've already used up all my numbers once, what I'm going to do is I'm going to use my tens column as an overflow. And instead of this just being empty, technically there are probably some zeros sitting here if I wanted to get technical about it, I have 0, 10s in all of these. I increment to 1. And I'm going to do this again, so my 1 stays here, and now I go 11, 12, 13, until I get to 19. I roll back around to 0, and I say I've used my digits twice. And you keep doing that until you get to 98, 99, and then this 9 rolls back around to 0, which means I increment this one. Well, incrementing this one means that I roll back through. I've used all those ones in my tens place once, so that becomes 0, which means I now have to put a 1 over here saying that I've gone through all of these 10 times. So that's just an interesting thing about numbers, really understanding how they work. We could do a whole lesson on bases and number systems, and it's kind of fun to do. Not necessarily we have to talk about here, but maybe we'll do that in class sometime. Before we're done with this video, I wanted to talk about number lines really quick. Number lines are a great way to visualize what's happening. It's a poor way to solve problems, but it's a good way to understand what's happening with a problem. So here's a number line. I put 0 in the middle, and we go positive to the right, negative to the left, all incrementing by 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all in one direction are negative numbers going back the other way. If I wanted to, I could take this same number line and I could add, that's not going to work. Let me zoom in a little bit so I can write a little bit neater. I could take these numbers and I could rewrite them to be negative 100, negative 90, negative 80, negative 70, negative 60. That's a 40. And then the same thing over here. Let's see if I can write these ones a little bit neater. This would be something like 10, 20, 30, 40, 50, not 78, 70, 80, 90, and 100. Number lines hasn't changed at all. I've just changed the increments. So I'm going to remove some of these. Let's just look at the one side for now. We'll look over here. Another thing I could do is I could add a decimal point. And if I put a decimal point in front of the first number only, I have the same thing. The number line looks the same. All I've done is I've shrunk it. When I put the zeros on there, I basically multiplied everything by 10. By putting a decimal here, I've divided everything by 10. All right, so one other thing we could do is we could just divide everything by a certain number. I have a number line here that deals with fractions, where that's a 1, 2, 3. But I can easily see where a third is, and 2/3, and 3/3, and 4/3, and all of that are. So number lines are a nice way to visualize what's happening. The last thing I want to show about number lines is as we get into our algebra, we've probably noticed this. Our graphs are nothing more than two number lines that one's rotated 90 degrees. So I have this one number line back and forth, this horizontal one here, and then I have the one that goes up and down right here. Those are just normal number lines. Positive goes to the right, positive goes up. And as I use these, I can use both of them independently and then see if I go a certain number in my x and a certain number in my y, where would I be out here in space? So graphs are nothing more than number lines, two number lines on the same spot facing different directions.